When we're trying to determine the total slack or float, this tells us the amount of time that an activity can be delayed, but not delay the project. So we saw in that previous example that we could delay B 15 days and still not delay the project. How long an activity can exceed its early finish date without affecting the project end date or an imposed completion date. It's simply the difference between the late start and the early start when using forward, or late finish minus early finish when using the backward pass. So then our free slack or float is the amount of time that an activity can be delayed after the start of a longer parallel activity or activities. It's how long that activity can exceed its early finish date without affecting any succeeding dates. It allows us some flexibility in scheduling of our scarce resources. Only activities that occur at the end of a chain of activities where you have a merge activity can have free slack time. When we're talking about the critical path, the network path that has the least slack in common. It's the longest path through the activity network. The critical path is the shortest expected time in which the entire project can be completed, and it's denoted in these projects with dotted lines. We want to make sure that it gets done on time, because anything in the critical path that is off schedule throws the entire project off schedule. It's where we would pay extra attention when we're doing risk management, where we might want to really monitor our activities. Our network sensitivity is the likelihood that that original critical path will change once the project is initiated. If a network schedule has only one critical path and then has other non-critical activities that enjoy significant slack time, that would be labeled as an insensitive project. There's only one way that we have a critical path. If we have multiple critical paths, then we can look at the sensitivity within the project to see how that project might alter and what non-critical activities we might have along with it, and we might change what that critical path looks like after we've already started the project. Other practical considerations we have when we're making this network is that we would have logic errors in the design of the network. Maybe we numbered the activities incorrectly and they ended up in the wrong order. We would use a numbering system that works within our own system when we're numbering those activities. We would also use computers to develop our networks and our Gantt charts and have calendar dates. In addition to using calendar dates when we're considering the start and stop of our projects, we also can have multiple starts and multiple projects. We're going to look at these in more detail. So network logic errors that can occur are that we have an illogical loop. Any looping doesn't work when we're making our network. In this example, we can't do B until we've finished A, but we can't do A until we've finished C. That doesn't make sense when we're trying to make our plan. So it's an illogical loop. Looping is not allowed in our networks. We see here, we're looking at the different systems, and we have calendar start dates and finishes, duration. We've connected them. We want to make sure we use charts. We can use a bar chart, which is also called a Gantt chart, where we can see that defined start and finish. We can see right here the duration and how the days overlap and how they might get done. When we're looking at additional network techniques, we have laddering. So laddering is when we break up activities into smaller segments so that we can begin things sooner and not delay the work. Legs are the minimum amount of time that an activity can be delayed to begin or end. So we want to break down lengthy activities so we reduce the delay in the start of a successor activity. We can use legs to help constrain the days that we have available between blocks. So for example, if we have a 25-day activity, we're going to want to break that activity into smaller segments so that we can keep better track of what is happening in those 25 days and what potential lag might occur in those 25 days. This is an example of using laddering to develop a relationship. So we've broken things up into 3 components. So we have trenching, laying pipe, and refilling that trench. So we can break that up into thirds and start working on different components. So once we have a third of the trench dug, we can start to lay a third of the pipe while we're digging the next third of the ditch. By laddering those components, we help start the next step in the process before completely finishing the first process. Otherwise, we would have to trench the entire length, then lay pipe, and then refill the trench in a normal path. By laddering, we can reduce or condense the amount of total time that project takes. And using legs between activities, we have a finish to start relationships. So from X to Y, we have a leg of 19. So then we look at these different activities, activity M, activity N, activity P, and activity Q. Leg is one of the ways we can help develop this slush or available activity within our project. When we see these start-to-start relationships, we can see between P and Q that we have this leg of 5. So what that looks at is that we need 5 units of Q. Q cannot begin until 5 time units after activity P. This helps us in developing that ladder relationship that we looked at in the pipe trenching. So where we would do a portion of P, then we could start part of Q and help build that in. When we're using legs in our project, then that helps us, gives us some flexibility with time. So this is a use of leg. We have 3 leg, so we have 1/3, 1/3, and 1/3 in our product, where over here with a leg of 5, we would have 1/5, 1/5, 1/5 when we're creating laddering. We also have this concurrent engineering approach. So in a traditional sequence approach, we would have product planning, systems engineering, engineering design, procurement, manufacturing and production, and quality assurance. In a new production development process, we're going to start laddering those items. So when we're partially done with the product planning, we're going to start systems engineering, and we're going to be more ahead of our time. This helps us condense the time products. This can be really useful when we're called to condense a project, which we'll do in a future chapter, where we have a project that for some reason we're going to have to reduce the amount of time we're able to spend on it. So we use this information from this chapter to know how to condense projects in future chapters. So this is also about those different legs. So we have a finish to finish relationship. So from the end of our prototype to the end date of testing, we have a leg of 4. From the start to finish relationship, it looks at from the start of our first component to the finish of the other one. And then we have combination relationships where we have the code and the debug, and we can look at the end to end or the end to start. So we have the end to end or the start to start. This is an example of a network using legs, and it is designed those in to our slack time, our early start and our early finish, our late start and our late finish. Remember that the dotted lines indicate a critical path. And we have A, B, C, D, E, and F are the components of our network. Hammock activities are used to show a controlled portion of the project, such as a fixed component of the project that spans over different segments of the project. It has a duration that is determined after the network plan is drawn, and it's useful in assigning and controlling indirect projects. It's used to look at sections of the project that might add on an extra level of information. For example, we might have a specific amount of time where we have access to a consultant. That consultant would be that Hammock activity, and we would want certain components of that project in which we need a consultant to overlap with the dates available to have that component. So here we have the consultant available for 8 days, and we want that to overlap B, D, and F dates. So that we want to make sure that we are working on those during the 8-day duration of that activity. So we would build in this Hammock activity of having that consultant available to us for 8 days. That is the end of chapter 6. I will also be posting an example video for chapter 6 homework example.